Okay, final review of the semester. First things first, uh, this is not test 13, this is going to be test 11. So go ahead and fix that on your review. Okay, so let's go ahead and take the first one. So it says graph one cycle and identify the key features. So I'm going to just kind of do the key features as we go. So the amplitude is found from the number in front, and it's never negative, so our amplitude is 2. The period, that one requires a formula. So I'm going to write this up top. The period is equal to 2 pi over b. And b happens to be the number that's in front of x. So that means in this problem, b is equal to 1. So if I put 2 pi over 1, that means that my period is 2 pi. Now the midline is usually found as the k value, and this one doesn't have a k value, so that means that my midline is y equals 0. And we'll do even, odd, or neither once we have the picture, and then we'll do domain and range once we have the picture. Okay, so here's what we need. We need to first figure out where the midline is going to go. We said earlier that the midline is 0, so this is going to be our midline down here. And the reason why that's important is because you have to kind of know your two shapes, and the amplitude is going to tell us how far to go away from the midline. Now the two shapes that I kind of asked you to memorize, the first one was a sine graph. Sine graph has 3 dots on the midline, and then it's got one high point in between the first 2 dots, and then one low point after the second 2 dots. So you get a curve like this. A cosine graph starts high and ends high, with the low point right in the center, and then in between the first 2 and the last 2, that's directly on the midline. So our cosine shape looks like this. So we know that this has to be a sine shape, so that means that the first 3 dots, they have to be on the midline. And because our period is 2 pi, that should be where the 5th dot is located. So I'm going to put the first dot here at 0, and then the last dot at 2 pi. The dot in the middle has to be literally in the middle. So the middle of 2 pi is 1 pi. And then if I go halfway in between the first 2, I have to go 2 spaces away, but it's a negative. So instead of going up, we're going to go down 2 and put a dot. And then I go towards the last 2 dots and go right in the middle. And then I have to go up. So we have a horizontal flip, or horizontal reflection. So our picture is going to look something kind of like that. So now that we have that, we can determine if it's even, odd, or neither. So this graph, it's going to be odd because any sine graph that passes through the origin is always odd. If this graph would have shifted up or down at all, then it would have been neither. Our domain is easy. We learned in class that the domain for both shapes is always negative infinity to infinity. And then our range is going to be the lowest point to the highest point. So that's our y value. So this is going to go from -2 to 2. That's our first answer. Okay, next, our amplitude is found in front, so that's a 3. The period, again, guys, this has a 1 in front, so it's just 2 pi. And then my midline is always found over here at the end. So my midline is going to be y equals -1. And make sure you put y equals, because if you just put -1, that's technically wrong. Then the rest of it we're going to get from the picture. Okay, so the first thing we're going to do is we're going to put the midline, because all points are based off that midline. So I'm going to put my midline down here. My midline is at -1. And I know because it's a sine shape, it's going to start right on the y-axis in the midline. And our period is 2 pi, so that last dot is going to end at 2 pi. Then the center dot is going to go here, right in the middle. Half of 2 pi is 1 pi. And then I go in between the first 2 dots, and that's going to be my high point. Now my amplitude is 3, so I'm going to have to go up 3 from the midline. So this is 1, 2, 3. And then same thing, I go to the last 2 dots, go right in the middle of those, and then I go 1, 2, 3 down. So then I get this curve. It goes something like this. and there's our shape. So now we can come up with the rest of our answers. So sine shapes can only be odd, but they have to pass through the origin. So that means this one is neither. Domain is easy. We should never miss this because it's always negative infinity to positive infinity. And then our range is going to be our lowest point to our highest point. So this is going to be -4, 2. So your range is always your y values from the bottom to the top. Okay, so this next one is kind of interesting because it's got too many points in my opinion. So I'm just going to tell you that 2 pi is the end of the graph. And then we have also a dot at, oh, hold on, I gotta fix that. At 2 pi, it's up at 2. So 2 pi is up at 2. And then at 0, that's also at 2. And then if I go straight to the middle, so I've already used these two, and the exact center of that would be right here at pi. So at pi, it's at 0. So now I got to try to figure out what's happening. So I'm going to go kind of in between the first 2 points that I plotted. So these are the points that are on the graph right now. So if I go right to the middle of this one, this tells me that it's at 1. So I put a dot right here. And then I go to the middle of the second 2 blue ones, and that one at 3 pi halves is at 1. So that means that the graph must look like this. So now to tell all of our information, we kind of have to figure out the amplitude. So what I'm going to do is I'm going to mark off the highest point and the lowest point. And that means that our midline is exactly in the middle of that. So that's our midline. So I'll actually start there. So my midline is going to be at y equals 1. The amplitude is the distance from the midline up to the highest point, and that's also 1. So my amplitude is 1. My period, it looks like it took 2 pi to complete the entire shape. And because this is starting high and ending high, this is a cosine graph, and all of our cosines are going to be even as long as there's no horizontal shift. Our domain is always negative infinity to infinity. And then our range is going to be the low point to the high point on the x-axis, or on the y-axis, excuse me. So this is going to go from 0 to 2. And notice again, we have these brackets. The reason why we have these brackets is because the points are colored in. We would use round parentheses if they were white dots, but they're solid. So, okay, next. This one, let's see what we got. We've got a 2 up in the front that tells us the amplitude. Now this one has a 2x, so the period is no longer pi. So what we're going to have to do is we're going to have to use 2 pi over b. And b is that 2 right in front of the x. So that means my period is pi. My midline is always located over here at the end. So this is y equals 1, and you have to write y equals. And then we'll get the rest of the stuff once we have the picture. So when we graph, we always graph the midline first. So my midline is at 1. And I know this is a cosine graph, so a cosine graph has to start high and end high. So if I'm at the midline, a cosine graph is going to be 2 dots away from the midline, and it's going to end. Now remember that our period is at pi, so it should end right about here. So it's going to start at 3 and end at 3. So that's 2 above the midline. Now the exact center of those points should be the lowest point of the graph. So I'm going to go below the midline 2 spaces. And then in between the first 2 dots, that should hit the midline. And in between the last 2 dots, that should also hit the midline. So our cosine graph is doing something like this. So now we can come up with the rest of our answers. Cosine graphs, they are always even unless there's a horizontal shift. Our domain is negative infinity to infinity because, like I said at the beginning, it doesn't matter if it's a sine or a cosine. These graphs, they're wave graphs, and they go forever to the left and to the right. And my range is going to be the low point to the high point. So -1 to 3. Brackets on both of those. Okay, next. amplitude. Now, amplitude is found in front, and you have to be careful because amplitude is never negative. The period, remember guys, anytime there's just a plain x here, that implies that b is 1, which means the period is 2 pi over 1. So anytime you just have a regular pi there, or not a regular pi, but a regular x in there, that means the period is 2 pi. Then our midline is always y equals, and it's always the number at the end. So this is going to be at -2. So when we graph, we're going to always mark the midline first. And then we have to know our two shapes. This is a cosine shape, so usually a cosine starts high and ends high. So I'm actually going to reverse that. So I'm going to start low and end low. You see my period is 2 pi, so it should be down here. Now the exact center of those 2 points should be above, so it's going to go 1 above. And then in between the first 2 dots should hit the midline, and in between the last 2 dots, that should also hit the midline. And remember, we don't want a V shape, we want it to be more curved. So it should look something like that. Now cosine graphs, always even unless there's a horizontal shift, which this one does not have. Domain is -infinity to infinity because it always is for both shapes. And then your range is going to be the lowest point to the highest point. So my lowest point is at -3, highest point is at -1. So it's always bottom to top. There's our answers. Okay, next we're going to graph the first and the last. So the first point is at 0. So we got 0, 2. And then the other one is at 2 pi is at 2. So 2 pi up to 2. So we've got these two graphed. So now I want the dead center. So dead center is at pi and 2. And then halfway in between each one would put us here. So at pi halves, it's up to 3. And then halfway in between the last 2 would be here. So 3 pi halves, that's going to be at, what is that, 1? Yeah, so it's going to be at 1 down here. So because of the way this is drawn, that's going to be our midline, because it has to be the same distance above and below. Those points have to be both 1 up and 1 down from there, because we know that amplitude has to be the same on either side. That also tells us a lot about the graph. This is going to be a sine graph because of the dot that's right here. That one right there starts at the midline, so that's how we know it's a sine graph. So our amplitude, it goes 1 above and 1 below, so our amplitude is 1. It takes all the way to 2 pi to complete the entire shape. Midline looks like it's at 2, so y equals 2. Now because this is a sine graph has to start at the origin in order to be odd. So this one's going to be neither. Domain is always -infinity to infinity. And then the range is going to be your lowest point up to your highest point on the y-axis. So that's from 1 to 3. Okay, so now we have to write equations based on some transformations. So just remember that your transformations work exactly like all the shapes that we've ever done this year. A is in front, H is inside, and K is at the end. So it says write the new equation, and it has to be translated right. So I'm going to leave the 3 in front. And because it's going to the right, usually right would be positive. So I'm going to make this a -3 pi in here. And then they want it to go up 2 units. Up and down movements are always at the end, so it's +2. Okay, number 8, they want this one translated pi 6 units to the left. So I'm going to keep this 1/2 sine, and I want it to go to the left. Left is negative, so that means this has to be a plus. So it's pi 6. They don't say to move it up and down, so I'm going to leave it where it's at -1, but they do say that it needs to be reflected across the x-axis, so that's a negative out in front. Okay, write the equation of the graph with the given amplitude and period in the form y equals a cosine of bx. So the amplitude is 4, so that always goes in front, so 4 cosine. And then if you remember from class, I told you guys, anytime your period is 2 pi, you don't have to do any math because that just means there's an x in here all by itself. So the next one says amplitude is 2/3. So I'm going to have y equals 2/3 cosine. Now this guy right here kind of messes everything up, so we have to do a little bit of math on this one. So I'm going to take the period formula, 2 pi over b, and I'm going to set that equal to 16. So if I make this 16 over 1, I can cross multiply. So I get b times 16 equals 2 pi times 1, which is 2 pi. To get b by itself, I just divide by 16. So the 16s cancel. Now this one's going to have a pi on it. We don't usually see that often, but that's okay. And if you reduce 2 over 16, it's going to give you 1/8. So I'm just going to turn the 1 into a pi. So we'll call it pi eighths, and then we'll stick the x in there. Okay, write the equation with the amplitude and the period. So another one just like what we just did, except now it's a sign. So amplitude always goes in front. That's your a value. Now this one doesn't have a 2 pi as our period, so that's where we have to do the math. It's 2 pi over b equals pi over 8. So we multiply those together, so it's b times pi. 8 times 2 pi is 16 pi. Then we just divide by pi. Causes both pi's to cancel, so b is equal to 16. So now we can stick that 16 over here in front of the x. That's our answer. Okay, next one, amplitude is 1. So if the amplitude is 1, you don't have to write anything. You could just write the sign. We're going to have an x in here, but we got to figure out what number needs to go in front. So I'm going to again do the little cross multiply thing that we've been doing. So it's 2 pi over b is equal to 12 pi. Put this over 1. So b times 12 pi equals 2 pi. Then we just divide by 12 pi. So all that cancels. These pi's cancel on the right, and then we're left with a 1/6. So b is equal to 1/6. That goes in front. Okay, target 3 is identifying the transformation. So you just have to use words and describe how the graph moves. So you have to compare the numbers before and after. So like, for example, this has a 1 in front, and now it switched to a 2. So that's going to be called a vertical stretch. Then you just had, looks like there was only an x right here, but then all of a sudden it's an x minus pi fourths. So anytime you put a number in here with x, that means it's moving sideways. So because of the x-axis. And remember that this one is always opposite. So if it's negative pi fourths, that actually means right pi fourths. Those are answers. Okay, next one. Looks like the only extra number it has is this -4 at the end. Now because that 4 is not inside with x, that's not left and right. So this one is actually just down. So that's down 4. That's the only transformation. Okay, a couple more. Let's see. This one has a few things. So usually this has a 1, but it switched to a negative and it switched to a 2. So that's actually 2 different transformations. So the negative is a vertical reflection. And then the 2, it went from a 1 to a 2. So that's a vertical stretch. And it also had the plus 2 pi inside with x, 2 pi thirds. This one is always opposite, so that's actually going to be left. It's going left because it's with the x in there. So it's left 2 pi thirds. Okay, next one, it went from a positive to a negative. So that's a vertical reflection. Then on the inside, it has a plus 3 pi in there with the x. So that means that we're shifting left because that one is, again, always opposite. So it's left 3 pi. And then we have this last number over here at the end that wasn't there before, so it went down 6. It says describe amplitude. It's basically the distance from the midline to the high point. I'm going to just put a slash and put low point so I don't have to write it twice. It says, what type of transformation creates a midline that is not y equals 0? So usually the midline is at 0, but when you change it away from 0, like let's say it's y equals 4, that's going to be a vertical reflection. Not reflection, vertical transformation, a vertical shift. Yeah, that's what we'll call it. So vertical shift. There you go. Okay, this one says the temperature in an office is controlled by an electronic thermostat. The temperatures vary accordingly to the function, where y is the temperature in degrees Celsius and x is the time passed in hours past midnight. It says, what is the temperature at 9 a.m.? So if the temperature is the time is 9 a.m., that means that 9 hours since midnight has passed. So that means t is equal to 9. So what we'll have to do here is we'll have to open up the calculator, because this is a calculator question. And we're going to have to just type it in. See if I can adjust this and change the view so I can see the equal button. There we go. So I want to make sure that my setup, if I hit setup, this needs to be in degrees, which it is, so we're good there. Okay, so what we're going to type in is, let's put this right here, 6 sine of pi 12ths parentheses 9 minus 11 and then plus 19. So we just literally type exactly what it looks like. I don't want that. Let me go back over here. So 6 sine pi halves. So shift exp. Oops. I need to add parentheses around this. Then I need this to be a fraction. So it's pi halves. Then I need a second parentheses with 9 minus 11 in there. Close the parentheses, close the second set of parentheses, and then plus 19. So this answer that it spits out is going to be the temperature, and that's in degrees Celsius. So it's 18.67 degrees Celsius. It says, how is the function shifted vertically based on the midline? So usually graphs have a midline at 0, but the number over here at the end shifts it either up or down. So this graph shifted up 19. Okay, now let's see, complete the table. So it says the amplitude, the midline, and the period. So the first thing I'm going to do is I'm going to mark off the high point and the low point, because that tells me where the midline is. So the midline has to be this line here. So my midline is going to be at y equals -1. And then my amplitude, it looks like it goes up 1 and it also goes down 1. So the amplitude is 1. And the period, because this has 2 dots on the midline, that means this is a cosine graph. So it's got to start high and end high. So my period is at 2 pi. Okay, and then the second graph, same thing. I'm going to start off by marking off the high point and the low point. So my midline is here. And because this has 3 dots on the midline, this is a sine graph. The amplitude is the distance from the midline to the top and the midline to the bottom. They're both 1 again. And then the midline is located at y equals +1. And then the period would be this guy right here, so that's at 2 pi. So it says compare the amplitude for the graphs of f of x and g of x. So which is which? This guy right here, this is our g of x. And the one previous, this was f of x. So they're asking us to compare the amplitude. So the amplitude of f of x is 1, and the amplitude of g of x is 1. So we would say f of x equals g of x. Number 23, compare the midline. So the previous one, f of x, had a midline at -1, and g of x had a midline of +1. So f of x is smaller than g of x. Then it says compare the periods. This one had a period of 2 pi, and this one also had a period of 2 pi. So that means f of x is equal to g of x, since their periods were exactly the same. It says, describe how you find the period for a sine and cosine graph given the equation. So if you have the equation, you just use 2 pi over b, and you just plug in the b value, which is found in front of your x. It says, describe the differences between a trig graph and a linear graph. So trig graphs are waves, and linear graphs, whoa, are lines. Very simple. I think our paper review has a few I think 4 review questions. I don't know why it's not on my sheet, but I have the answer key posted on the front wall. So if you're interested in looking at the answers to the final 4 questions, which is, again, it's just a distributed practice, so it's all old stuff, feel free to just check out the review that's posted on the front wall. Last test of the semester. Let's finish strong.